Welcome back. Stage 03 begins, and we're locking the fleet down. P1 is behind us, installed, networked, observable. Now we harden every layer, starting with the firewall. And we're doing it the modern way. nftables, the Debian default since 11, replacing legacy iptables with cleaner syntax, atomic rule loading, and native sets. By the end of Lesson 12, your rule set reads policy drop, and only SSHD, NGINX, and your app are listening. So why nftables? And why now? 6 rows, 1 verdict, where iptables needs 4 separate binaries: iptables, iptables tables, arptables, ebtables. NFT handles every protocol in one tool. Rule replacement is atomic, so you never get that flush and reload gap where the firewall is wide open. Sets are native, no ipset package to bolt on. The syntax is named and declarative, JSON-friendly for automation, and the inet family covers IPv4 and IPv6 in one rule set, no more duplicating logic. iptables NFT exists as a shim for legacy fleets, but on anything new, you go straight to NFT. Before you write a single rule, internalize the hierarchy. Tables contain chains, chains contain rules, and chains hook into specific points in the kernel's packet path. A packet arrives, hits pre-routing, then the routing decision splits it. Destined for this box, it goes to input, where your firewall lives. Passing through, it goes to forward. For a typical server, you need exactly one table init filter with 3 chains: input, output, forward. Master that mental model, and every NFT command stops feeling like magic. With the model clear, here's the rule set we actually ship on every Dargslan server. Read it top to bottom. Flush rule set gives us an atomic replace, no window where the box sits naked. Then input gets policy drop, which is the whole game. From there, we whitelist exactly 4 things: loopback, established and related connections, ICMP for both protocols, and ports 22 and 443. Everything else hits the counter and gets logged with an NFT drop prefix so you can grep DMES and see who's knocking. Forward is dropped because this isn't a router. Output stays open because we trust ourselves. That's your production baseline. Append app ports, never loosen the policy. Now, before you load that rule set on a remote box, do the safety dance. Step 1. Schedule a flush in 10 minutes with it. That's your dead man's switch. If you lose SSH, you just wait it out. Then apply the rules with nft-f. Open a second SSH session to confirm you're still reachable, and only then cancel the rollback with ATRM. Once you've survived, persist it by enabling nftables service. Verify with nftlist rule set, and grep for counter to see which rules are actually getting hit. This workflow has literally saved careers. Never skip it. With the rule set live and persisted, let's level up with 2 patterns you'll use constantly in production: named sets and rate limiting. A set is just a typed named collection. Here, sh-allow-list holds your trusted admin IPs as an interval set, and sh-block-list uses the timeout flag so entries expire on their own. Then, in the input chain, block-listed sources get dropped first. Allow-listed admins skip the rate limiter entirely, and everyone else gets 4 new SSH connections per minute. Exceed that, and we use add-block-list inline to auto-jail the offender for an hour. The real superpower, NFT add element, lets you blocklist an IP atomically at runtime. No reload, no flush, no downtime. Now, a firewall you can't see is a firewall you can't trust, so let's bolt on observability before something breaks. Drop the counter keyword in front of an action, and nftables accumulates packets and bytes per rule, queryable anytime with nftlist rule set. For the default drop path, chain a log prefix with level info, rate limit it to 10 per second so a scan can't flood journaled, then drop. From there, journal ctlk out, grep nft drop gives you live attack telemetry. And that one-liner with grep, sort, and Unix surfaces, your top reconnaissance sources for the day. In stage 04, these same counters get scraped by Node Exporter into Prometheus for fleet-wide dashboards. Now, plenty of you are inheriting Debian 10 boxes still running classic iptables, and there are two clean migration paths. Path 1 is the compatibility shim, point update alternatives at iptables nft, and your old commands keep working, while the rules live in nftables tables underneath. Path 2 is the proper rewrite. Iptables save, then iptables restore, translate to generate native NFT syntax, inspect it, simplify it with the inet family, and drop it into @nftables.conf. Whichever path you pick, heed the warning at the bottom. Never run netfilter persistent and nftables service together. They will fight, and you will lose. Migration aside, let's talk wrappers, because not every box needs hand-rolled NFT. UFW gives you trivial syntax. Default deny, allow sh, allow 403, enable, 4 commands, and you're done. Firewalled brings zone-based thinking, which shines on container hosts and mixed rel Debian fleets. Both write nftables underneath, so you're not giving up the modern backend. But for production Dargslan fleets with complex rule sets, native NFT wins on control, atomicity, and speed. Pick the tool that matches the team, not the trend. Now the war stories, 5 gotchas that will bite you in production. Number 1 is the classic. You push a rule, SSH dies, no KVM, and your cloud provider wants $50 for rescue console. Run the safety dance from slide 5 every single time. 2, never leave iptables and nftables both active. Mask 1. 3, forget CT state established, related, and your outbound replies vanish. 4, rate limit your log statements or journaled evics everything. And 5, use the innet family, or your IPv6 surface stays wide open. So that's lesson 12 in 6 moves. You know why nftables wins. You can build tables, chains, and rules. You've shipped a default drop rule set. You've internalized the SSH safety dance. You've layered rate limits with dynamic sets. And you've wired counters and logs ready for Prometheus in lesson 19. Stage 3, coin hardening, is officially underway. Next up, lesson 13, SSH hardening itself, the bridge into the SSH mastery track. One closed door, one well-locked one. Firewalls closed, but an open SSH port is still an open door. Lesson 13 takes you straight into hardening it. Keys only, no passwords, modern ciphers, and KEX algorithms with the legacy cruft stripped out, and match blocks for per user and per IP policy. It's also your bridge into the SSH Mastery Cross course, 5 courses deep on one protocol. Default drop behind you, hardened daemon ahead. Load lesson 13.